Alright, so let's move on to the subtopic 6.2, which is about equilibrium constants. So here's the learning outcomes for 6.2. By the end of the lesson, you should know how to define homogeneous and heterogeneous equilibria, write expressions for equilibrium constants in terms of concentration, Kc, and pressure pressure, Kp, for homogeneous and heterogeneous systems. Use the equation Kc is equal to Kp times with Rt to the power of n to solve equilibrium problems. Calculate Kc, Kp, or the quantities of species present at equilibrium. Determine the degree of dissociation. And lastly, predict the direction of net reaction by comparing the values of Q and K. So what is homogeneous and heterogeneous equilibria? Okay, homogeneous equilibrium ni ialah chemical equilibrium di mana reactants, kalau if let's say you ada reactants A and product U B, mereka berada di phase yang sama sahaja. Okay, kalau heterogeneous equilibria, dia punya reactant dengan produk dia tak sama phase dia. Okay, contohnya let's say if you have reactant A, produk kamu B, so dia punya reactant ni contohnya in aqueous phase, B ni in gas phase. Okay. Okay, in subtopic 6.1, you have learned how to write the equilibrium law ataupun law of mass action, di mana equilibrium constant is equals to the concentration of product to the power of product divided by concentration of reactant to the power of reactant. Okay, so dekat 6.2 ni, dia lebih mendalam sikit. So, equilibrium constant ni hanya bukan K sahaja. You need to express it sama ada dua sahaja expression dia, which is Kc ataupun Kp. Kalau Kc ni ialah equilibrium law expressions yang di mana you boleh expresskan fasa gas dengan aqueous sahaja. Okay, so Kc ni ialah equilibrium constants in terms of concentration. So that's why as you can see here, bila dia nak write the equilibrium constant tu in terms of concentration, dia boleh follow the definition of the equilibrium law, which is the concentration of product to the power of product divided by the concentration of reactant to the power of reactant. So as you can see here, bila you nak build the Kc expression, fasa-fasa yang berada dekat reactant dengan produk mestilah sama ada aqueous ataupun gas phase. Kalau let's say dia pure liquid ataupun pure solid, you tak payah write langsung benda tu dekat expression dia. Okay, so if you can see the examples here, the reactant ada dengan produk ada campur-campur aqueous dengan gas phase. That means this system is a heterogeneous equilibria. Okay, tapi disebabkan dia memenuhi kriteria untuk kamu write the Kc expression, which is sama ada you boleh choose dia aqueous ataupun gas phase. That's why you boleh write it in terms of concentration. So you buatlah dalam kurungan concentration of product to the power of product divide by concentration of reactant to the power of reactant. Dengan syarat, kalau you nak guna Kc expression ni, kalau let's say dia punya chemical equation tu tak kisahlah di bahagian reactant atau produk hanya ada aqueous ataupun gas phase sahaja yang boleh diterima. Kalau Kp expression, Kp ni ialah equilibrium constants in terms of partial pressure. The way you want to write it is just the same like this one, tapi this one is in terms of partial pressure. So, kalau in terms of partial pressure, it will be partial pressure of the product to the power of product divided by the partial pressure of the reactant to the power of reactant. Okay, dia punya perbezaan dia ialah kurungan dia. Kurungan dia kat sini ialah macam lebih bulat sikit lah. Yang ni ialah kurungan simbol untuk concentration sahaja. Okay, and then kalau partial pressure kita tahulah P besar ni ialah partial pressure. Tapi kalau you nak cari Kp, you boleh expresskan Kp kalau let's say tak kisahlah reactant ke produk ke hanya ada gas phase only. Okay, kalau let's say you nak build Kp expression, for example, you nak build Kp expression, tiba-tiba produk dia yang D ni dalam aqueous phase. So, bila you nak build KP expression, you jangan includekan lah yang aqueous phase ni. Kiranya nanti D ni tiada langsung. Dia jadi partial pressure of product C to the power of C stoichiometric coefficient ni divide by the partial pressure of reactants A and B with diorang punya respective power stoichiometric coefficient ni lah. Okay, kalau let's say D ni dalam aqueous phase. Kalau let's say dia bukan dalam aqueous phase, dia dalam gas phase, you bolehlah include dia di dalam KP expression, okay? Okay, jom belajar macam mana cara-cara nak build KC and KP expressions if kamu diberi a reversible chemical equation. Okay, you need to bear in mind as what I told you earlier, if let's say kalau sesuatu compound tu berada di dalam pure solid ataupun pure liquid, you need to remember you tak boleh includekan dia di dalam KC ataupun KP expressions. Okay, for example 1, if you look at this reversible chemical equation, you tahu this is actually a heterogeneous equilibria. Okay, heterogeneous equilibria. Sebab kenapa? Reactant dengan produk dia are in different phases. Okay, so sekarang ni kalau you nak buat equilibrium law ataupun law of mass action punya constant, you bolehlah buat K is equals to concentration of the product to the power of product bahagikan concentration of reactant to the power of reactant, kan? Tapi kat sini, if let's say you want to build equilibrium constants in terms of concentration, which is Kc, ataupun equilibrium constant in terms of pressure, which is Kp, you kena tengoklah phase dekat compound tersebut. Okay, for example, kalau Kc dia hanya boleh accept aqueous and gas phase. Kalau Kp dia hanya boleh accept gas phase sahaja. So if you look at this equilibrium law constant, okay, hanya CO2 sahaja yang ada gas phase. Therefore, kita bolehlah ignore CaO and also CaCO3 just because both of them are in solid phase. Okay, in pure solid phase. So you boleh abaikan sahaja. You anggap dia sebagai constant sahaja. Okay, constant dekat dalam ni konteks dia berbeza pula maksudnya. Tapi senang cerita you boleh ignore je. So and then you build lah Kc expression. So Kc is equals to concentration of CO2, concentration of product. And then actually patutnya divided by the concentration of reactant, since that reactant dia in solid phase, so that's why you tak include. Okay, Kp ialah equilibrium constant in terms of pressure, so you boleh describekan dia in terms of partial pressure for each of the species here. But since that CaO and CaCO3 is in a pure solid phase, so you boleh ignore sahaja. You boleh terus buat Kp ataupun equilibrium constant in terms of pressure is equals to partial pressure of CO2 sahaja. Okay, if you look at the next example, okay, this is a heterogeneous equilibria juga. Okay, sebab kenapa? Because dia punya reactant dengan produk dia are in different phases. Ada solid, ada liquid lah, and ada gas lah. Okay, so as usual, if you build dia punya chemical equilibrium constant, yang macam biasa punya, okay, it will be concentration of product to the power of product divide by the concentration of reactant to the power of reactant. Tapi if let's say again, if you want to build Kc expression, equilibrium constant in terms of concentration, you kena make sure you hanya boleh terima aqueous ataupun gas phase sahaja. Okay, so if you look here, Fe3O4 is in solid phase, so you boleh abaikan. Lepas tu H2O dan juga Fe ni pun in a pure solid and pure liquid phase, so you boleh abaikan diorang dua ni juga. So dia tak akan ada lah, you tak akan include dia di dalam Kc expression. So your Kc expression is just gonna be concentration of hydrogen gas to the power of stoichiometric coefficient dia 4 to the power of 4. Okay, how about partial concentration? You nak express Kp. Kalau you nak express Kp, Kp ialah equilibrium constant in terms of pressure. Dia hanya boleh terima gas phase sahaja. Therefore, you buatlah Kp is equals to partial pressure of hydrogen gas to the power of 4. Alright, so let's move on to the next example. As you can see, you have this heterogeneous chemical equilibria again. Because reactant dengan produk dia, phase mereka berbeza-beza. So again, if you want to build Kc ataupun Kp expressions, you boleh mulakan dengan build the equilibrium law constant dahulu, di mana concentration of product to the power of product bahagikan dengan concentration of reactant. Okay. Kalau you ada dua, there is going to be a multiplication of them lah. Okay, so as you can see here, if you want to build a Kc expression, Kc ni ialah equilibrium constant in terms of concentration. Okay, dia hanya boleh accept compound yang ada gas phase ataupun aqueous phase sahaja. So, bila you tengok dekat chemical equation ni, you boleh tahulah yang mana yang you boleh masukkan dalam Kc expression sahaja, which is concentration of CO2, just because of dekat produk ni hanya CO2 saja ada gas phase. Fe ni ialah pure solid, so you boleh ignore it totally, and then divide by reactant concentration of CO sahaja, is because of FeO ni di dalam solid phase. Okay, so we can totally ignore that. How about Kp? Kp ialah equilibrium constant in terms of pressure. So kalau if you want to build Kp expression, benda tu mestilah in only gas phase sahaja. Okay, aqueous phase dia tak terima. So as you can see at this equation, okay, CO2 sahaja yang ada gas phase. Yang lain ni solid, aqueous, solid, so tak boleh guna langsung. That's why Kp will only be equals to partial pressure of CO2 gas sahaja. Okay, so next, let's look at the next example. Okay, macam lebih kurang je kan, tapi I ada tukar-tukar lah phase kat sini. Okay, so basically, this is a heterogeneous chemical equilibria again. So if you want to build the Kc or Kp expressions, you boleh build the chemical equilibrium law constant dahulu, which is the concentration of product punya multiplication divide by the multiplication of concentration of reactants. Okay, so kalau Kc again dia hanya boleh terima sesuatu yang di dalam gas phase ataupun aqueous phase sahaja. But in this case, as you can see, dia punya produk Fe and also CO2 berada di dalam pure solid phase and pure liquid phase respectively. Therefore, you can just ignore both of them. Okay. So bila you ignore, mathematically it's gonna be 1 ke atas tu. Okay. You jangan buat kosong pula walaupun you ignore. You letak satu sahaja. Okay. So bahagikan dengan concentration of CO gas sahaja. Is just because FeO ni di dalam solid phase. Okay, so we can cancel it out. Okay, next ialah Kp expression. Kp dia hanya boleh terima sesuatu yang in gas phase sahaja. Again, yang ada gas phase hanyalah CO gas. Yang lain ke atas ni reactant, all in a pure solid and liquid phase, and this one pure solid phase, you can just ignore them. Tapi bila ke atas ni you ignore, you jangan letak kosong, again you letak satu. Okay, so it's going to be 1 over partial pressure of CO gas. Okay. Okay, how can you relate Kp and Kc together? Okay, consider you have this general homogeneous equilibria reversible chemical reaction, because dekat bahagian produk dengan bahagian reactant mereka semua in gas phase. Okay, so if you build the Kc expression for this above general equation, it's going to be concentration of product C and D H raised to the power of C and D, dia punya stoichiometric coefficient, divide by the concentration of reactants A and B H raised to H stoichiometric coefficients small letter A and B. Okay, and Kp pula ialah partial pressure of product to the power of product divided by the partial pressure of reactants to the power of reactants. Okay, so assume that if the gas behave ideally, you know that PV is equals to nRT. Okay, sekarang ni kita fokus pada Kp expression dululah, because we know that kalau kita jadikan pressure as a subject, is gonna be P is equals to N over V RT. Okay, and number of mole divide by the volume kan adalah formula untuk concentration ataupun molarity. Betul tak? Okay, so what if partial pressure of A, B, C dan D ni, you buat masing-masing dalam bentuk N over V RT for each of them. So we know that N over V is equals to formula untuk concentration ataupun molarity. So we can conclude that partial pressure of A is equals to concentration of A times with RT. Same goes to B, C and D as well. Alright, next, once kita dah tahu partial pressure of A is equals to concentration of A RT, partial pressure of B is equals to concentration of B RT, and same goes to C and D as well. So we can substitute partial pressure of A, B, C and D yang kita dah buat di dalam bentuk concentration ni di dalam KP expression. So kita masukkan KP is equals to concentration of C RT to the power of C kalikan dengan concentration of D RT to the power of D bahagikan concentration of A RT to the power of A times with concentration of B RT to the power of B, which in this case kita boleh singkatkan, kita boleh kumpulkan concentration C, D, A and B ni in one section. So bila kita kumpulkan concentration of C to the power of C, concentration of D to the power of D divided by concentration of A to the power of A, concentration of B to the power of B, this one dia macam melibatkan matematik sikit lah. Bila you dah groupkan this one in one group, bila you nak kalikan sekali RT ni, bila you kalikan sekali RT, dia tak akan hilang tau C, D, A and B ni. So C dengan D, kalau let's say stoichiometric coefficient di atas ni is going to be plus because kali kan, kalau bahagi tolak A and B. Okay, so what we can conclude here is when you want to relate KP and KC together, you can use this equation. KP is equals to KC because this one is KC expression. Okay, so KP is equals to KC times with RT to the power of delta N. Okay. Yang ni actually expression dia macam the way how we can derive this is not that important. What is important is you kena hafal formula ni. KP is equals to KC times with RT to the power of delta N. Okay. Okay, so basically at the end of the day you just need to remember this. Okay, derivation tu tak tahulah penting sangat ke, tapi kalau let's say you tak hafal dia punya relationships, mana satu nak letak KP ke KC kat depan, you kena ingatlah that derivation it shows that KP ni, daripada KP ni you boleh dapat KC expression and then times with RT delta N to the power of delta N. So what is KP? KP ialah equilibrium constant with respect to pressure. KC ialah equilibrium constant with respect to concentration. Okay, R ialah gas constant which is 0.08206 liter ATM per mole per Kelvin. T ialah temperature. I'm sorry, I forgot to put here. T is temperature. Temperature must be in Kelvin. Okay. Lepas tu delta N ni apa? Delta N ni is actually the total mole of gaseous products minus with the total mole of the gaseous reactant. It's because why? Tadi kita nampak total mole of gaseous product dia C plus D minus with A plus B. Kan? Macam itulah dia. Okay. Tapi kalau let's say dia punya delta N ni is equals to 0. So dia punya formula ni is gonna be KP is equals to KC times with RT to the power of 0. You tahu kalau RT to the power of 0, anything yang to the power of 0 will be equals to 1. Mathematically, this one is equals to 1. Okay, so bila dia equals to 1, KC kali 1 kan KC. Therefore, if let's say delta N, dia punya total number of mole of gaseous product minus total of mole gaseous reactants ni is equals to 0, you will get KP is equals to KC. Okay, apa benda ni nanti adalah kegunaan di kemudian nanti ya. Okay, for example, if let's say you have these reversible chemical reactions, okay, before you nak kira-kira KP, KC, RT, delta N ni, you kira dahulu delta N dia before you nak kena buat jalan kerja yang lagi lengthy. So, because kenapa? Because once you tahu delta N ni is equals to 0, it's a piece of cake because you know that KP is equals to KC. Okay, for example, how do you know that this is equals to 0? Okay, this is all in gas phase, right? Okay, lepas tu produk dia adalah 2 mol. Okay, produk dia 2 mol. Lepas tu dia punya reactant 1 campur 1, 2 kan? 1 campur 1, 2. So, 1 campur 1 ialah 2 moles juga. Okay, so 2 moles produk tolak dengan 2 moles of the reactant is equals to 0. So that's why save your time, Kp is equals to Kc. Okay, so you can test yourself by doing this exercise first untuk tahu nak kira macam mana delta N ni. Okay, contohnya yang A ni, kenapa answer dia 3? Okay, how do you know that dia punya delta N is equals to 3 is because, okay, kalau you nak kira delta N ni, you kena ingat, you hanya boleh libatkan anything yang in gas phase sahaja. Okay, gas phase only. So if you can see at the reversible chemical reaction A, yang gas phase hanyalah ada di bahagian produk saja, which is this 3O2. Okay, this 3O2. That's why delta N kan is equals to number of mole of gas products tolak dengan number of mole of gas reactants. Since that tak ada apa-apa nak ditolak pun, so answer dia 3. Okay, untuk B pula, okay, yang ni obviously will be 0 since that they in solid phase. Okay, so we will put this 0 sebab dia solid. Yang ni pun 0. How about this? This is gonna be 1. So kalau 0 product minus with 1 because this is the number of mole total dekat bahagian reactant, it's gonna be negative 1. Okay, that's how you do it. So the next ni you bolehlah figure out on your own. Okay. Okay, kenapa tadi you kena belajar pasal the formula yang melibatkan relationships between Kp and Kc, di mana kita akan tahu the relationships dia akan generate a formula Kp is equals to Kc times with RT delta N, di mana if let's say delta N tu is equals to 0, it will save you a lot of kerja where you can conclude that Kp is equals to Kc. Okay. So, untuk this kind of formula and information, you can look at jenis question example 1 ni. Dia bagi tahu equilibrium concentrations for reaction between carbon monoxide and molecular chlorine to form COCl2 at 74 degrees Celsius are as follows. Okay, dia suruh kamu determine the equilibrium constants Kc and Kp. Kat sini lah baru kamu boleh gunakan this kind of formula. Okay. So first thing first, soalan macam ni, dia tak bagi tahu direct tau, dia punya balance chemical equation. So what you need to do is you need to build one. Okay. So first thing first, you buat sketch biasa-biasa je dulu, which in this case dia bagi tahu reaction ni between carbon monoxide. So carbon monoxide is CO, and then molecular chlorine is Cl2, and then dia kata akan dapat produk COCl2, right? Okay, so you must be thinking, oh, this must be the chemical equation, but nope, you have to look here. Dia suruh kamu cari Kc and Kp, and ada perkataan equilibrium concentrations kat situ. So dah sah-sah lah, this gonna be a reversible chemical reaction. So you kena ubah the arrow tu, okay? And since that, dia suruh kamu relatekan Kp and Kc, and then you must know that you must be using this kind of formula. So everything must be in gas phase, okay? Alright. And after that, you try lah balancekan them out. So you look here, oh, it's already balanced. Okay. So sekarang ni, kita tengoklah solution yang sebenarnya dekat next slide. Okay, dia dah bagi tahu equilibrium concentrations for each of these species. Okay, kenapa perlu perkataan equilibrium concentrations? Because okay guys, kalau dia dah suruh kamu cari Kc and Kp kan, Kc dengan Kp ni kan ialah equilibrium constants. Sudah tentu sudah pastilah kalau let's say you nak masukkan anything dekat dalam this expression, it must be in equilibrium juga. Okay, so for example, if you build Kc expression for this chemical equation, reversible chemical equation, you will get Kc is equals to concentration of product COCl2 divided by concentration of reactants CO times with concentration of Cl2. Okay, this kind of concentrations ni wajib kena ambil equilibrium concentrations. Because dah kata pun K ni equilibrium constant kan, so everything must be in equilibrium juga. Okay, so tak apa, soalan ni dia bagi direct, so it's fine. So you tahulah concentration equilibrium untuk COCl2 is 0.14, concentration equilibrium untuk CO is 0.012, concentration equilibrium untuk Cl2 is 0.054, and you will get Kc ialah 216. You kena ingat jawapan untuk Kc dengan Kp adalah dimensionless. Dia tak ada unit. Okay? No unit. Memang macam tu. Memang dia tak ada unit. So, you jangan pelik-pelik. Okay? So, sekarang dia suruh kamu cari Kp. You can relate Kp dengan Kc by using this formula. Kp is equals to Kc times with RT to the power of delta N. Okay, temperature tadi dia bagi in degree Celsius. So, since ada gas constant, anything ada gas constant, penglibatan gas constant, okay, temperature dia kena jadi Kelvin, pressure kena in atm, volume kena in liter. Tapi tak apalah, it doesn't matter. Kat sini dia hanya mahukan temperature saja. So the temperature must be in Kelvin, so you need to convert the degree Celsius to Kelvin, which you will get 347.15 Kelvin. How about the delta N? Delta N, you tengok balik dekat dia punya reversible chemical equation that we have built before. So we know that the product ada 1 mole of gas. Okay, product 1 mole. Reactant ada 1 campur 1 equals to 2 moles. Okay, so kat sini you kena buat a little bit of calculation lah, since that the delta N will not be equals to 0. So you know that Kc tak akan sama dengan Kp. So you kena buat extra calculation sikit lah. Tak apa, jangan risau. So kat sini you tahu delta N you will be equals to -1. And you already know the relationships between Kp and Kc punya formula. So you masukkan saja Kc punya value that you have calculated before, which is 216, times with R, gas constant, 0.08206, times with temperature that you have converted into Kelvin, which is 347.15, and R dengan T ni, you memang kena multiplykan dia, but then it needs to be to the power of -1. So you tekan-tekanlah calculator you. I hope that your Kp value is 7.58. Again, Kp dia tak ada unit. No unit. So you need to remember Kp and Kc is dimensionless. Okay, because diorang tak ada unit. Okay, jangan memandang nak letak unit. Okay. Alright, so you can make this out as your homework. Okay, to test your understanding about Kp and Kc punya relationships just now, which we know that Kp is equals to Kc times with RT to the power of delta N. Okay, tapi kat sini dia dah bagi tahu dah nilai Kp apa, Kc apa. So, berpandailah you gunakan information yang ada untuk cari apa benda yang tak ada. Sebab dia suruh cari both kan. Tapi dia bagi tahu salah satu saja. And also you kena ingat delta N ni ialah the difference number of moles between gaseous punya number of moles of product minus reactants. Okay, untuk B ni nampak ada solid kat sini. So you kena berpandailah kira number of mole untuk B ni kalau dia ada solid. Okay. Okay, untuk test yourself tu pun benda ni pun melibatkan formula Kp is equals to Kc times with RT delta N, because why? If you can see here, dia bagi kamu information untuk Kc. Okay, lepas tu dia suruh kamu cari, tak adalah suruh kamu cari Kp. Okay, dia suruh kamu cari one of the species di dalam Kp expressions. Okay, because if you look at this chemical equation, you know that Kp is equals to partial pressure of oxygen times with partial pressure of N2 divide by the partial pressure of NO to the power of 2. Tapi dia bagi kamu Kc sahaja. So I hope that by using this kind of information, you carilah Kp. Once you have found the Kp, okay, I tak tahulah berapa nilai Kp tersebut. you dah tahu partial pressure of oxygen gas dengan nitrogen gas apa, and you need to find the partial pressure of NO. Tapi ada to the power of 2 kat sini. So bila you jadikan dia sebagai subject, it's going to be a square root of everything. Okay, so nanti you boleh try this out juga.